Bismillahirrahmanirrahim. Assalamu alaikum, dear student. I do hope you will be in best of your health. In today's lecture, we will learn left hand and right hand derivative limit. So let's start with today's lecture. Uh, First, I will give you a preview of the previous lecture. In the previous lecture, we have studied slope of the tangent line. The slope m of a tangent line to the graph of a function at point P is defined as slope of at point A, limit h equal to 0, f of A plus h minus f of A divided by h. By considering this definition, we will define the derivative. Actually, the slope of the tangent line is called the derivative. The derivative of a function f is the function f prime whose value at x is given by f prime of x is equal to limit h approaches to 0 f of x plus h minus f of x divided by h provided that this limit exists. It means that this definition of the slope of the tangent is actually the definition of the derivative. Slope of the tangent line is called derivative. I do hope it will be clear now. Now we proceed toward exercise question exercise number 2.2. Question 1 to 4. Uh, First part A, use definition 2.4 to find f prime. Second, find the domain of f prime, and in C part, find an equation of the tangent line to the graph of f at P. In D part, find the point on the graph at which the tangent line is horizontal. We will do question number 1. F of x is equal to minus 5x square plus 8x plus 2 at point x minus 1 and y minus 11. Uh, the definition of the derivative is f prime of x is equal to limit h equal to 0 f of x plus h minus f of x divided by h. First, we will find the value of f of x plus h by putting x plus h in the question. F of x plus h will be equal to minus 5 x plus h square plus 8 x plus h plus 2. And opening the square, we will have the value of f of x plus h is equal to minus 5x square minus 5h square minus 10xh plus 8x plus 8h plus 2. Using the value of, let us label it this formula as equation number 1. Using the value of x plus h and f of x in equation number 1. Using the values of f of x plus h and f of x in equation 1, we have f prime of x is equal to limit h equals to 0 minus 5x square minus 5h square minus 10xh plus 8x plus 8h plus 2 plus 5x square minus 8x minus 2 divided by h. Cancelling the term with opposite sign, cancel minus 5x square with plus 5x square and plus 8x with minus 8x and plus 2 with minus 2. After cancelling this term, f prime of x is equal to limit h equal to 0 minus 5h square minus 10xh plus 8h divided by h. Taking h common from the numerator, and cancelling with the denominator, we will have f prime of x is equal to limit h equal to 0 minus 10x plus 8 minus 5x minus 5h 5h minus 10x plus 8. If we put the value of limit h equals to 0, we have 8x plus minus 10x plus 8, the value of the derivative. Now, in B part, we have to find the domain of f prime. As f prime of x is equal to minus 10x plus 8, this is a polynomial function. There is a denominator involved in it. So its domain will be set of whole real number. It can be shown by r or minus infinity to infinity. In C part, we have to find the equation of the uh, equation of find the equation of the tangent line to the graph of f. We have to find the equation of the tangent line at P. So using the point slope form, y minus y1 is equal to m into x minus x1. The value of x1, y1 is given as point P, which is minus 1 comma minus 11, and the value of the slope will be determined by using the value of x in f prime of x. M is equal to f prime of put x is equal to minus 1. We will get the value of the slope is equal to 18. Now using the value of p and slope, we have the equation of the tangent line, which is y plus 11 is equal to 18x plus 1. In the D part, we have to find the situation when the tangent line will be horizontal. At when tangent line will be horizontal, its slope will be equal to 0. That is, slope is, we have denoted the slope with derivative. M is equal to f prime of x is equal to 0. Slope will be 0. So f prime of x is equal to minus 10x plus 8 is equal to 0. From here we can find the value of x is equal to 5 by 4. Now to find the y value of the y, we will put this value in the initial question. Y is equal to f of x is equal to minus 5 into 4 by x, which is the value of x square, plus 8, 4 by 5 plus 2. And after simplifying, we will get the value of y is equal to 26 divided by 5. X comma y is equal to 4 by 5 comma 24 26 divided by 5. This is the value, this is the point where the tangent line is horizontal. Now we will define the left hand and right hand derivative limit. Uh, Function f is differentiable on a closed interval ab. This definition actually used when we study the derivative on some particular interval. So a function f is differentiable on closed interval ab if f is differentiable on the open interval ab, and if the following limit exists: limit h equal to 0 plus, this means this is the right hand limit, f of a plus h minus f of a divided by h, and limit h equal to 0 minus, which denotes the left hand derivative at point b, f of b plus h minus f of b divided by h. Now this is the interval we have the interval a to b, and this is the graph of function f of x. We have drawn the tangent line at a and tangent line at b. uh, as at a, we will find the right hand limit. It means that we will approach the limit x equal to a from the values greater than a. This means that we will approach limit from the right hand side, as from left hand side there is no path. It means that at a we will find the value of the limit right hand limit, and at b we will find the left hand value, as there is no path from the right hand side. We will approach the limit uh, as a proceed to 0 for values greater than for values less than b. This is the value of the left hand This is the definition of the left hand and right hand derivative. Now we will do some question using the left hand and right hand limit. Exercise 21 to 22 is f differentiable on the given interval explain. This will be done with the help of right hand and left hand derivative limit definition. Question number 21, 1 divided by x. 1 divided by x. In the we have to check the differentiability in the interval 0 to 2 and then 1 to 3 open interval. First, we will determine the differentiability in interval 0 to 2. This is the definition of the right hand derivative limit h equal to 0 f of a plus h minus f of a divided by h. Here, the value of a is equal to 0 and value of the b is equal to 2. For right hand limit, we will put a is equal to 0. Limit h equal to 0 f of 0 plus h minus f of 0 divided by h. And we put the value of function h in this uh, question. We will get f of h is equal to 1 divided by h, and f of 0 will be 1 divided by 0, which will be infinity, and divided by h. As the uh, in numerator there is infinity, so this limit does not exist. Uh, Now we will find the left hand derivative limit. Limit h up to 0 minus f of b plus h minus f of b divided by h. Here the value of b is equal to 2. Limit h up to 0 f of 2 plus h minus f of 2 divided by h. The value of f of 2 plus h will be 1 divided by 2 plus h, and f of 2 will be 1 divided by 2 h. Taking the LCM of the numerator and simplifying, we will get limit h equal to 0 2 minus 2 minus h divided by h into 2 plus h into 2. 2 will be cancelled with minus 2, and we will have limit h equal to 0 minus h divided by h into 2 plus h into 2. And cancelling the h from the numerator and denominator, we will have limit h equal to 0 minus 1 divided by 2 plus h into 2. Now this is the same in the simplified form. Now putting the limit h equal to 0, we will have the right hand derivative limit is equal to minus 1 by 4. Uh, Now, as the right hand limit does not exist, and uh, left hand limit exists, but it is necessary for a function to be differentiable is that both the right hand derivative limit and left hand limit should exist. Now the right hand limit is not exist, uh, so f is not differentiable on the interval 0 to 2. Now we will check the differentiability of this function in interval 1 to 3. Uh, at 1 the interval is closed, and at 3 the interval is open. Limit h equals 0 f of a plus h minus f of a divided by h. Now the value of the a is equal to 1. F of limit h equals 0 f of 1 plus h minus f of 1 divided by h. Now value of the f of 1 plus h is equal to 1 divided by h, and f of 1 is equal to 1. And now taking the LCM of the numerator, we will have limit h equal to 0 1 minus 1 minus h divided by h into 1 plus h, cancelling 1 with minus 1, and we have limit h equal to 0 minus h divided by h into 1 plus h. Cancelling h from the numerator and denominator, we have limit h equal to 0 minus 1 divided by 1 plus h. Now this is in the simplified form. Uh, Putting the value of the limit, we will have the right hand derivative limit is equal to minus 1. Now we find in a similar manner the value of the left hand derivative limit h equals 0 minus f of b plus h minus f of b divided by h. The value of b, now here we have 3. Limit h equals 0 f of 3 plus h minus f of 3 divided by h. The value of the f of 3 plus h is 1 divided by 3 plus h, and f of 3 is minus 1 by 3 divided by h. Taking the LCM of the numerator, and we have limit h equal to 0, 3 minus 3 minus h divided by h into 3 plus h into 3. Cancelling 3 with minus 3, we have limit h equal to 0 minus h divided by h into 3 plus h into 3. Cancelling h from numerator and denominator, we have limit h equal to 0 minus 1 divided by 3 plus h into 3. Now this is in the simplified form. Putting the value of limit, we have the uh, value of the left hand derivative is equal to minus 1 divided by 2. As the right hand derivative limit and left hand derivative both limit exist, so hence f is differentiable on the given interval from 1 to. Now we will do some question of some uh, absolute function. Exercise 33 to 36, use right hand and left hand derivative to prove that f is not differentiable at point A. 33 number question, f of x is equal to x minus 5 mod, and we have to check the differentiability at A is equal to 5. Now uh, I will expand this absolute function using the definition of the absolute. F of x is equal to x minus 5 absolute may be written as x minus 5 when x is greater than or equal to 5, and with the minus sign x minus 5 when x is less than 5. Uh, we will find first the value of the function at a. Uh, a is equal to 5. F of 5, 5 minus 5 is equal to 0 mod, and 0 mod is equal to 0. Now to check left hand and right hand limit, we will use the definition of derivative at point A. The definition of derivative at point A is equal to f prime of A is equal to limit x approaching to A, f of x minus f of A divided by x minus A. This is the definition of the derivative at some particular point A. Now we will use this definition and concept of the left hand limit and right hand limit to check the differentiability. Limit x approach to a plus f of x minus f of a divided by x minus a. It means that we will find the limit for values greater than x greater than a. For x greater than a, here the value of a is equal to 5. It means that we will approach the limit for values x is greater than 5. For x greater than 5, the value of the function a, here we have x minus 5. Using this, limit x equal to 0, x minus 5 minus uh, f of 5 is equal to 0 divided by x minus 5. Limit x equal to 0, x minus 5 divided by x minus 5. Cancelling x minus 5 from the numerator and denominator, we have limit x equal to 5, 1, and value of the limit or constant is same, and then limit x equal to 5 of a function f is equal to 1. Now we will find the left hand limit. Limit x equal to a minus f of x minus f of a divided by x minus a. It means that we will find the value of limit from values less than 5. For values less than 5, we have the function's value minus into x minus 5. Using this, limit x equal to 5 minus into x minus 5, and value of f of 5 is 0 divided by x minus 5. Uh, Cancelling the same factor from the numerator and denominator, we have limit x equal to 5 minus 1, and the value of the limit of minus 1 will be equal to minus 1. Now the as the left hand as the right hand limit of the derivative is 1 and left hand derivative limit is minus 1. Left hand derivative limit is not equal to right hand limit, so f is not differentiable at. For differentiability at one point, it is necessary that the left hand derivative limit and right hand derivative limit should equal. Now we in this question, the left hand derivative and right hand limit are not equal, so f is not differentiable. So, dear student, I do hope the concept I try to clear the concept of left hand derivative limit and right hand derivative limit. I do hope you now can understand this concept. If you have any question, you may ask me online class. Till then, take care of yourself. Allah Hafiz.